Hopefully, you've had a moment to go through the lecture practice problems and try them all yourselves. Now, I'm going to walk through the solutions so you can see how I would approach these problems. So, our first one is looking at a patient that has a mass of 70.3 kilograms, and we need to convert this into units of pounds. And we're lucky we're given a conversion factor that actually converts between pounds and kilograms, which says that this is going to hopefully be then a shorter calculation. So I'm going to start with a piece of information that I know. I know the patient is 70.3 kilograms. I know I need to convert that, and I'm hoping it's one step. And that'll end up in a unit that's pounds. So I'm going to take my pounds unit and put that on the top of my conversion factor and my kilograms on the bottom so they cancel out. And I have a conversion factor that relates pounds to kilograms. So I can go ahead and just plug in the values in that equality into my fraction conversion factor. So that'd be 1 kilogram, matching this one right here, and 2.2 pounds. So I'll put a 2.2 on top. So I'll multiply this out in my calculator, and I get a value that is 154.66 pounds. Great, simple enough. Before I'm done, I'm going to double check my significant figures. The patient was weighed, so they have a mass of this 70.3 kilograms. And so that's three significant figures and one decimal place. I'm using multiplication. So that means I'm going to use my least number of significant figures rather than my least number of decimal places. And so I need to report this value to three significant figures. That is going to require dropping off these digits after the decimal place. And one of them's the first one's a 6. So I need to actually round up when I do that. So my value is actually going to be 156 pounds. And that will be my correct answer. Our next question is conversion for a recipe. So we're making a cake. A pound of flour is what I'm being given. So right away, I'll go through and highlight these. Being told the recipe calls for a pound of flour, and I need to convert that mass of flour into the units of cups because I don't have a kitchen scale, let's say. I know I need units of cups, and I'm starting out with pounds. I'm seeing a few conversion factors that I have. 1 pound of flour is 453 grams, and a cup of flour is 120 grams. Already, just from the problem, I can tell this isn't as simple as a one-step conversion. So I'm going to make a strategy using my units. So my starting point is that 1 pound of flour. And I know that I need to get to cups. No matter what, I want to have a conversion factor that includes pounds, so I can set it up as a fraction with pounds on the bottom so they cancel out. And I need a conversion factor with cups, and I need it to be on the top of a conversion factor fraction, so that way I end up with units of cups that it doesn't cancel out. And I don't have a pounds to cups conversion, so we'll have to do something else. Looking at my given conversion factors, I'm told that a cup of flour has a mass of 120 grams. So I know I can go between cups and grams. And the other conversion relates pounds to grams. So when I set up my conversion factor to get rid of pounds, I can convert into it. So looking at this, I can see that my units will cancel appropriately if I just use these two conversion factors. My pounds will cancel and my grams will cancel, leaving me just with cups. If it helps to look at it written out as if I multiplied all of these things, it would be pounds times grams times cups divided by pounds times grams. And so we can see these, if they're variables, would cancel out. All right, so now I can just plug in some values and some numbers. So I have 1.0 pounds. I'm going to multiply that by my grams to pounds conversion factor. So that's 453.6 grams comprise 1 pound. And I have 1 cup in every 120 grams. So if I plug this all into my calculator, I'm going to get a value that's 3.78 cups. I'm going to look at my significant figures now before I finish. I need to weigh out this 1 pound. And so it hasn't happened yet, but I'm going to treat it like it has happened. So I can say, oh, I should apply these 2 significant figures to my answer. Now, these 2 conversion factors are exact numbers, so I won't look at the number of significant figures those values have. I'll just work with my inexact number, the 1.0 pounds, and I'll now report my answer to 2 significant figures. Again, this is going to require rounding up my last digit of my number as I drop off the remaining ones that I have, that 8. So this is going to become 3.8 cups. All right, now we're going to try the third problem. And this is another conversion factor based on a medication. This one's going to be acetaminophen. And just looking at it right away, I'm like, it's a big block of text. So whenever I see this, I actually start highlighting things in the problem. So that way I can focus on the information being given rather than all the other words around it. And sometimes it helps to list them out on the side. So we can do that as well. So I'm going to highlight as I go. Let's get a different color. So an adult with a fever needs to take a dose of acetaminophen, but only has children's liquid acetaminophen available. An adult dose of acetaminophen is 2 tablets every 6 hours, and each tablet contains 500 milligrams of acetaminophen. Children's acetaminophen contains 160 milligrams in 5 milliliters of the liquid. The only measuring device in the house is a jigger, which is one that where one end holds a volume of 1.5 ounces, which is equal to 44 milliliters, and the other end holds 1 ounce. Of which side of the jigger should be used to measure the acetaminophen and what volume should be taken. I feel like this actually was written off of a really bad time when I had a fever, and this was all I could figure out. So let's list out the information that we have. We need to take 2 tablets every 6 hours. Each tablet is 500 milligrams. So I'm going to write that as an equality to really tell myself it's 2, or it's a conversion factor. So 1 tablet equals 500 milligrams of acetaminophen. And I know that children's acetaminophen has 160 milligrams in every 5 milliliters of liquid. I also know that 1.5 ounces is going to be equal, and these are fluid ounces, to 44 milliliters. And my 1.0 ounce I don't have, but I could figure that out by converting into ounces, like how many milliliters that jigger holds. And so I'm really trying to decide, am I using this 1.5 or this 1.0? So rather than focus on the first question, there's 2 here, of which side of the jigger should be used. That's going to ask, was it 1.5 or 1.0? And what volume should be taken. Let's focus on that because it will tell us, once we know the volume, it'll tell us which side of the jigger to use. Okay, so then what is our starting point, right? Our starting point is this 2 tablets right here. And it's every 6 hours. And since we just want to find out how much is being taken, we don't actually have to figure out how much is being taken over a period of time. So I'm going to ignore that 6 hours. It doesn't seem like it's going to be very useful to me in this calculation since I don't have a question at the end of the problem that asks about time or relative to time. So I'll start out with 2 tablets. And is 2 tablets an exact number or an inexact number, right? I'm going to measure out 2 tablets by picking them up with my hands, but the 2 tablets are, I count them, right? Like there's no way to um, estimate when I'm counting 2 tablets out that I'm counting, oh, maybe I accidentally counted 2.1 because they come as whole tablets. So this is really an exact number because it's a counting number. But we'll come back to that. So we're starting with 2 tablets and we're trying to get to ounces. So that way we could decide which side of this jigger to use. So I'm going to start by putting those ounces on top of my last conversion factor and tablets on the bottom of my first. Looking at the conversion factors that I've built here, I have a conversion factor that includes tablets, and each tablet has 500 milligrams in it. So I can get into units of milligrams. And looking at my ounces, I can see that I have 1.5 to 44 milliliters, and that's really going to be able to give me a conversion between volume here. So I can go between ounces and I can go between milliliters. So I can convert between those two using that conversion factor right here. Milligrams and milliliters need to cancel out though. And looking at my conversion factors, I have one that does that, that relates between milliliters and milligrams. I'm going to make sure that the milligrams goes on the bottom so it cancels out with the milligrams on the top of this first conversion factor here. And then I'll put milliliters on top. So let's check and make sure all of these will cancel out. So I have tablets on the top and the bottom, milligrams on the top and the bottom, milliliters on the top and the bottom, and I only have 1 ounces. So I should be able to, based on my units, go between tablets and ounces with this setup. So let's go ahead and do that. I've got 2 tablets. I'm going to multiply that by my 500 milligrams for every 1 tablet. And then I have 5 milliliters of children's medication. I have 160 milligrams. And I have 1.5 ounces to every 44 milliliters. Okay, what does that equal? So if I plug that into my calculator, I'll get a value that's 1.06534 ounces. If I want to round at this point, I can. Since all of our conversion factors are exact, so is our tablets. I'm not measuring anything and I'm counting. I could keep all these significant figures. I can also round since I'm trying to figure out which jigger to use. If I did round, so it replicated the 2 tablets, it would look like 1 ounce. And so I'm going to look at this number here and say, all right, it's just 1 ounce. Great. Then I'm going to use the 1 ounce side of the jigger. And take a shot of children's acetaminophen. Okay, our last problem for our Chapter 1 practice problems from lecture. Here we have fishing weights, and this is a problem that came from a student who worked as a commercial fisherman and was like, talk to me about how my lead and my tungsten weights are different sizes, but drop at the same rate. So the density of lead is 11.34 grams per milliliter. I'm going to write that all on the side as I read the problem. So density of lead is 11.34. And the density of tungsten is 19.25 grams per milliliter. Assuming the lead and the tungsten fishing weight have the same mass, so the mass of my lead equals the mass of my tungsten, but I don't know what it is. If the lead fishing weight is measured to have the dimensions of 5 centimeters by 1 centimeter by 1 centimeter, what's the volume of the tungsten fishing weight going to be? Okay, so I know that the volume of the lead fishing weight is equal to 5.0 centimeters times 1.0 centimeters times 1.0 centimeters. And I can calculate that here in a second. And I want to know what is the volume of the tungsten fishing weight. So this is my goal right here. I'm trying to figure out that volume of tungsten, and I've got a lot of starting information. However, I would argue that it's easiest to think of things like density as conversion factors because it has 2 units. I could actually rewrite this density as 11.34 grams equals 1 milliliter, and 19.25 grams equals 1 milliliter. So these are conversion factors. I don't know the mass, but my starting point then I think is going to be this volume of lead. So calculating that out, this 5 centimeters by 1 centimeter by 1 centimeter, I can calculate a volume that's 5.0 centimeters cubed. It's useful to note that 1 milliliter equals 1 centimeter cubed, or cc, right? Centimeter cubed is abbreviated cc in medical settings typically. All right, so I'm going to start with that 5 centimeters cubed. And I'll convert that into milliliters. All right, so I have 5.0 milliliters for my volume of lead. I need to figure out this volume of tungsten, and what seems to connect the two is this equal mass. And I can go between volume and mass using density. So I'm going to convert this into the density of my lead. So I have my 5.0 milliliters times my 11.34 grams per milliliter. And that will give me the mass of my lead weight. And I know they're equal. So once I know the mass of my lead weight, I know the mass of my tungsten. And if I need to be in volume of tungsten, I would be using that density to convert. So here's my lead density. I'm now going to use my tungsten density to convert into milliliters. So I want 1 milliliter divided by my 19.25 grams, and this is for tungsten. So I'm seeing that my milliliters will cancel, my grams will cancel, and now I'm in milliliters for my tungsten. And so when I calculate that out, I get a value that is 2.94545 milliliters. So if I am working with 2 significant figures here, I'm going to report 2 significant figures as well for this. So I'm at 2.9 milliliters. And I can convert this into centimeters cubed if I want as well, if I like the symmetry of knowing them both in terms of their dimensions. And so that would be 1 centimeter cubed divided by 1 milliliter equals 2.9 centimeters cubed. And so this fishing weight will be smaller than my lead fishing weight. And that, if I'm double checking that, that seems reasonable to me because the density is larger. And so a equal mass will be in a smaller volume. Or if I had 2 that were the same size, the tungsten would be heavier.